Welcome to the next meeting, the April meeting of the New York JavaSIG. We have a very, very exciting topic tonight. Thank you all for coming. And thank you to the people of the future that are going to watch this video on our channel. Welcome to the brand new JavaSIG members. So those of you who have joined recently, my name is Frank Greco. Normally, I don't chair these meetings. We have our illustrious leaders team that does this, but this is a special topic that means a lot to me and to our speaker, Frank Liu from Amazon. Excuse me, just doing some admin here. And I want to be sure that you people out there that are brand new, that everybody follows us on, here's our website, and then here's our Twitter handle. Please follow us. That's where you get a lot of information about the group and our meetings and our our hands-on workshops. Also, please subscribe to our YouTube channel. If you're watching this on YouTube, you're already in our YouTube channel. So the name of the channel is NYJavaSIG, where we have all of our meetings for the past 10 years there for our videos. And also, please join our mailing list. We have some very interesting Java discussions on our mailing list, and they're hosted on groups.io. So just look for, go to groups.io, which is a very good email service, and let's look for NYJavaSIG, and you'll find us. So, I mean, before I turn everything over to Frank Liu to talk about DJL and deep learning, just a few announcements. I wanted to thank Andres Almery for the talk on Larry last month. That was an excellent talk, so thank you, Andres. And our next meeting is at the end of this month, the 22nd of April, where Almas, let's call him Almas B, since I can never pronounce his last name. It's too long for me. I'll choke. Almas B. We're going to have a little bit of a change from our topics. We're going to talk about something kind of cool, FXGL game engine. So if you're building games and you want to use Java, and we all know that the gaming industry is bigger than Hollywood, so there's a lot of business in gaming, and it's not just for games, but for other applications like learning environments where you need a lot of animation and interactivity. So that's going to be very, very interesting on the 22nd. And one note about that, it's for people that are in the New York area, it's at noon, 12 o'clock. It'll be recorded as usual, but for New York people, it'll be noon. Another announcement, we have some changes coming to our mailing list that I just mentioned before. We had our main group, and we also had our announcements group, and we've had many, let's call them suggestions from our audience that we need to change things a little bit. So what we're going to do is make the main mailing list where you can hear all about announcements of the user group of the JavaSIG and our work groups, our workshops, etc. So that'll be just for announcements, and we are going to phase out the announcements group. So over about 6 months, we're gonna deprecate it now, and we're gonna get rid of it in 6 months. We're really gonna super deprecate it. And so we're going to fade out the announcements since people didn't like that too much. And we're going to have a new group called discussions, or guess what's going to happen there? Discussions. So, and that's a group that we'll put information in an email to everybody. If you want to join a group where you're going to hear about discussions, hence the name discussions, you're going to join that subgroup or mailing list. If not, just don't join. So you're going to miss out on all the fun. Another announcement is, again, thank you to our sponsors. We have 2 sponsors, Agile Learning. Actually, we have 3 sponsors. We have Agile Learning, Venkat's company, which is awesome content. We have JetBrains is another sponsor, and both Agile Learner and JetBrains are sponsoring a raffle. So during this presentation, in the chat, you'll see a URL for a Google form where you could sign up for the raffle. And Agile Learner is giving us, Venkat is giving us a free 1-year access to all of his courses, which is pretty awesome. And JetBrains is giving away. I have free 1 license, but I believe it's like 2 or 3 licenses, right, for any JetBrains product, which is again, that's really cool. So thank you both to Agile Learner and JetBrains. And our third sponsor is Azul Systems, which is a longtime sponsor of ours. So thank you, Azul. One last announcement before, again, I turn over to Frank. So the last meeting, we started a after meeting. So if you want to, since we can't get together physically, hopefully soon, we'll get together the way things are going, hopefully soon, maybe in the summer sometime, we can get together physically. But until then, we have an after meeting. So we'll post the URL to that meeting that follows this one. So if you want to kind of go over the meeting, we'll talk about machine learning, or you just want to talk about anything else. You want to talk about sports, or you want to talk about cooking or anything like that. Anything where you want to talk with a fellow JavaSIG member, like we used to do at the bar across the street from Credit Suisse. So we'll post that URL there. So feel free to jump in. So now let me turn things over to Frank. So Frank Liu, who I've worked with on visual recognition JSR, is with us this week, and Frank is the creator of Deep Java Learning, DJL. So he's working in the Amazon machine learning group. And again, he's responsible for a very, very cool framework that you all should know about. So Frank, it's all yours.
All right, thank you. Thank you for the introduction. So let me share my screen. Okay. Okay. This is Frank. I have more than 20 years of Java experience, and earlier I had a hard time to learn machine learning. Once I have this opportunity, I think I would like to make it easier for Java developer to learning machine learning. So that's why I'm passionate about building these tools and trying to introduce this one to the Java developer and make it easy to the Java developer so that they can build and deploy the AI applications in Java easily. So who is the audience of the DJL? So pretty much every Java developer can use DJL. It doesn't matter you have any deep learning experience before or not. So DJL is deliberately make it easy for Java developer to enter in machine learning and learn machine learning as well. So in order to do that, we build like a model zoo. So basically we have a lot of built-in models that are ready to use to solve certain machine learning problems. We have more than 70 models, the pre-built models in our model zoo. We have some of the Java developers doesn't have any machine learning experience before. They're using our models to resolve the real world problems. And also we made it like a transfer learning easier. So using the pre-built, the pre-trained machine learning models with your data set to solve your specific problems easily. So we make this one much easier to make your own models. This doesn't require you train the models from the scratch. And we also have a DJL 0 we introduced recently is a tail order for those users that doesn't know much about machine learning, but trying to solve really want to train your models from the scratch. So we make this one also easier. So you can just follow the certain steps to get your own models. And furthermore, we have a DJL serving. It's a serving solution. Once you get the model, there's a lot of PyTorch, the TensorFlow, MXNet pre-trained models out there. So you can use DJL serving to directly serve those models without writing code. So those are the mechanisms we made DJL. It's so easy for the users that doesn't have much deep learning experience before. For users that already using deep learning, like today, most of the deep learning frameworks are in Python. For those guys already know deep learning and already using deep learnings, DGL also a good choice for you to make your deployment much easier and simple. And we provide a unified API and make you like a lot of like the enterprise, they're not using one framework. They're using the mixed collection of TensorFlow, PyTorch, MXNet, Onyx runtime, all kind of models. The benefit of UDGL is we unified all the APIs. You write one set of code, you can deploy all the different type of models, make the migration and the switch over between engines much easier. So for those DevOps, right? So they love DGL. So because we make the deployment the very smooth. So we're going to talk about this one later. So DGL is ready for the production use. Yeah, so why using DGL for machine learning? So there's already a lot of solutions out there, right? So but most of the deep learning solutions are in Python. Right? Python is dominant in the machine learning right now. But for the enterprise customer, right? They are using they have like a lot of Java developers and they are running tons of the Java applications. Using Java to deploy machine learning, it's a natural choice for those enterprise. Because they already have the Java infrastructure and framework in their as a part of their solutions. And also there's so many big data applications like Spark, Kafka, Beam, Flinks, and they are all Java and Scala based. Those applications is very hard to integrate with Python based solution. So today there's not many like Java supported framework like for those the frameworks. DGL filling the gap. And using the DGL, you don't need to do the Java and the Python like the RPC costs. So this actually significantly reduce the overhead. So based on our test, this the memory consumption and the latency were significantly reduced. DGL support Java native like the multi-threading capabilities, make it very easy for the Spark user and parallel computing, which is not possible when using Python. So we see like when using the Java compared to the Python solution in those the big data applications, we got up to 85% of the reduction of the latencies. Also, there's so many Android applications out there, and they are all Java-based applications. So DGL make it possible to deploy the deep learning easily on the Android applications. And as I mentioned, DGL unified the APIs between the frameworks. When the technology moves, you may get the new models running better on the one engine versus another engine. DGL make it simple when you switch one engine to another. And also, DGL is not just the engine itself. It also comes with the NumPy like multidimensional the computation the support. So make it easy for general usage as well. And also we have the ease of use, and this is a key to the DGL. So if you are writing the deployment code, you only need 3 lines of code to deploy the model in production. I will show you later in the demo. So as I mentioned, like DGL support the multidimensional the computation. Multidimensional computation is the foundation of the machine learnings. In Java, there's a lack of this kind of support and have a demand for a long time. So for now, it's we utilize the framework's capabilities, and we define the Java-based NumPy-like operators. We currently support more than 60 math operations in the multidimensional array computation. DGL support MXNet, TensorFlow, PyTorch, Onyx runtime, Paddle. We support a lot of like native engines, and we can load the models and run the inference, which trained from those the Python-based engine. We create the abstract layer to make sure the API, the work the same behavior across the board with engines. So switching engine is just a configuration change. DGL provide the models. I already mentioned that we provide more than 70 pre-trained models for out-of-box deployment. DGL is very stable. So this is we run the test for a long time to guarantee there's a memory leak. There's no memory leak, and we carefully on each release and trying the provide the best performance and using the multi-threading environment. And we spend a lot of time to reduce the GC, and this is ongoing effort. We are still trying to make the GC issue for production use. Let's talk about the advantage of the DGL. So first of all, it's ease of use. We create the abstract API for inference case. You only need 3 lines of the code to run the inference. Basically, it's you load the model, create the predictor, and run predict to get the result. DGL itself is very lightweight. When we develop a DGL, we very carefully to choose our dependencies. So we have a very minimum dependencies, and it's very clean. So the core Java binaries are very small. So the API layer is only less than 3 megs total, including the dependencies. And the DGL is very performant. So we avoid the RPC call between the Java and the Python. So basically everything running in the same process. And this significantly reduced the latency. And we are supporting the multi-threading inference. And we can maximize the throughput and utilize your hardware capabilities. And also the memory consumption is small because we don't create a multiple process. And the memory it's the shared between the each models and the inference the workers. Because we are in Java, we are just pure Java library, and you can just write a code and run anywhere. So it makes it very easy to integrate with streaming applications like a Kinesis, like a Kafka. Yeah, and the DGL is very stable. So we have a lot of customers running DGL for long, like durable services, and like every release we run like long times of the benchmark testing to make sure the inference is stable. Next, I'm going to talk a little bit about the DGL architecture. So in this the diagram you're going to see here in the bottom level, it's just the operating systems and hardware layer, and in the middle is the C++ layer, which we leverage on. Basically, is we are leveraging the engines, native engines like MXNet, PyTorch, TensorFlow. We are not using the Python library. Instead, we are using their C API. And we build the different the bindings to communicate with the native layer. For example, when we build the MXNet layer, we're using the MXNet C API, and we use JNA to access their C API. And for PyTorch, we build the JNI layer directly. And for the TensorFlow, we're using Java CPP to communicate with the TensorFlow C API. And above the C layer, we have the Java engine layer. So this is the core of the DJL like implementation. So we build this adapter layer. So for each engine, we build a layer to abstract out. This layer is guaranteed the implementation is the consistent across all the engines. So when you call the DJL API on all the engines, they behave the same. And on the top layer is the API we provided for user to use. So we build the high-level construct like the model concept, like the predictor, like a trainer, like ND array. So we provide those APIs to abstract out the difference between each engines. And we designed it to make it easy for Java user. So this is not a simple wrapper of the Python API. Instead, we build a brand new APIs specifically for Java developers. So you can use your familiar Java design pattern to writing the code. So here's the model, like the typical like inference case. So you can see here the box in the blue box here is the code. You load the model, create a predictor, and run the prediction. When we design the API, we specifically make it simple to hide some of the detail that the Java developer not familiar with. For example, like how to do the mathematical computation, how to do the n-dimensional array calculation, all kind of stuff. Instead, you see here. So we define the input and output in the Java object. So when you load the model, the return the zoom model contains the generic of the image and object detection. The image class is the input. So we have an abstract image class that you can run it and you can get the result. The result will be detected object. This is also a plain Java object. So once you load a model, this model is capable to run the prediction on an image and return the detected object. Because of in order to handle the multi-threading the case, we create a predictor for this one. So each thread you can create a predictor, and they are sharing the same underneath the models. So once you create a predictor, it's very simple, and you can just run the predictor.predict and pass in the image, and you get the object back. So it's very simple. Yeah. So we also create a Spring Boot starter applications to make it easy for user to using the pre-trained model and deploy in the service microservice environment. So you can use our Spring Boot starter and just add the injections and the YAML file to configure your beans. Then you can use beans to run the predictions. And because the Spring Boot already have a integration in the IntelliJ, so you can use the autocomplete to easily create this YAML file. You can see here in this screenshot. Sorry, you can just using the autocomplete features. When you deploy a model, what you need to do is you select what type of the application you are using. For example, you say, my application is doing object detection that detect the object inside the image. And then you choose what engine to use. You can choose between MXNet, TensorFlow, PyTorch. And you specify the input class, output class, right? And then using our Spring Boot starter, you can create your microservice easily. So with the Spring Boot starter, make it easy to do a configuration-based deployment. You can change your configurations, change models, change model versions, all kind of stuff, just by the modify the configurations and without changing your code. Let's talk about some of the use case that DGL it's widely used currently by our customer. So one of the major usage in the DGL for the machine learning is on Spark. So Spark Spark user mainly is Java and the Scala users. So supporting the Spark, make it very easy for those users. So we build like the Spark Hadoop the extensions, so allow you to use DGL to load the models directly from HDFS or S3. So make this make the deployment very, very simple. So we handled all the heavy lifting work by this extension. Internally, Amazon retail team using the DGL deploy on the Spark workflow, and they reduced the 70% of the development time they projected with DGL. DGL is work very nice on the many of the AWS services. Depend on the use case. You can choose between Lambda, ECS, Beanstalk, the SageMaker. So for the microservices, if you have a small model and you don't, the latency is not that sensitive, it's very nice. You can choose AWS Lambda to deploy your deep learning models. So far, DGL is the only viable solution that can directly deploy on the Lambda. Because of the size and the memory constraint. So make it very like a DGL, it's easily can run inside the Lambda footprint. Using Lambda, it's very, very cost effective. So a millionth inference to the Lambda is only a cost like a few bucks. So it's the most cost effective the deployment solution. If your solution if your model is large, and you can consider the ECS. So ECS provide like a bigger footprint, and it can auto scale. So the management effort is minimized. If your model have a very critical latency requirement, you can also consider deploy Elastic Beanstalk or managed by your own EC2 as well. So DGL is very flexible. You can use multiple ways to build your microservices using DGL. If you really want a full managed service, they said I don't want to manage the ops work. So you can choose the Amazon SageMaker. It's a full managed service. DGL have a DGL serving solution, allow you to easily deploy on the SageMaker. Here's the app we developed on the Android applications. So we have a demo here. So if you scan this the QR code, you can find this the apps on Google Play Store. We published on the Google Play Store. You can try it. It's pretty the nice applications. You can play with it. It's a doodle draw application. Basically, in the screen, you can just draw a doodle, and we are going to predict what you are drawing and give you the probability. So you can see here on the Android framework, DGL runs super smooth. There's no laggage at all. So this handle the you can see like you can find the code in our demo repositories. I will post the link later about where you can find this source code. Yeah, so we built a lot of demos, and we have a demo repositories. We understand that machine learning is not easy, and we are trying to provide the tutorials, provide the all kind of the materials, help Java developer on board with the deep learning. So we create a Jupyter notebook with tutorials, examples, instructions, how to do it. Later, I will do a live demo about our Jupyter notebook. Those Jupyter notebook it's very easy to install and very run. And you can run the interactive code inside the Jupyter notebook. It's very suitable for the learning. So also we work with the Dive into Deep Learning book. So Dive into Deep Learning is widely adopted. The deep learning, the textbook is already adopted by many the colleges, and it's right now it's have a different like the translation as well. So we made it. The original book was written in Python. So with DGL, we implement this book with all Java. So this book is targeted for the Java developer. All the examples in Jupyter notebook format, you can directly run, and you can test it, modify it, and try yourself. We publish those the books, and in the browser, you can just use in the browser to open it. And most of the almost all the notebooks in the book, you can directly click on the buttons to run directly in the browser. So this book is the first Java deep learning book that have a live code in the Jupyter notebook. So here is our website, like a demos. We have a GitHub web demo website. You can find the examples on the Spark, for the Flink, and for the AWS the services usage. For example, Kinesis, Beanstalk, EMR, Lambda, etc. And also the Android, the applications, you can find our GitHub as well. The machine learning, the Spring Boot application starters is in a different repository, and the link is also posted here. So our website is the DGL AI, and in the DGL AI you can find all the links almost. And we have a docs DGL AI website for our online documentation, and the GitHub repository is listed here. Our main repository is the AWS Labs/DGL. And the website of the online book is also posted here. Yeah, and also we have a Slack channel here. So join us and post questions to DGL.
Would now be a good time to ask some questions?
Sure. Before the question, I have one ask as well. So at the end, we are going to post a survey. So please help us to fill in the survey. Yeah. So now we can have some Q&A.
And just to be clear, I think we have a demo coming, but I wanted to get in some questions before we did the demo. The first question is a little bit long. You mentioned there were about 70 pre-trained models early on.
Mm-hmm.
The question is, can you give an example of a few types of such models that exist, like conceptually what they do, and how you go through a list of 70 things efficiently to find the one you want?
Sure. I will do a demo later as well. So first of all, is we partitioned the models by applications. Basically, there is two major currently we have two major domains. One is the computer vision. Another is the natural language processing, NLP. So inside the computer vision, we further break down the applications. Like, for example, the image classification problem. The image classification problem is like, I want to classify the image is dog versus cat, right? This is typical like classification problems. And then there is the object detections, detect what inside the image. And we also have the action recognition. For example, what action you are doing, this is for human body. So for example, are you running? Are you doing some activities? This kind of thing. So basically, is we break down by applications and navigate through the applications, and you can find the models. What you need, and also like for the natural language processing, we have models. For example, question and answer, sentiment analysis, and all kind of this kind of we break down by applications, and inside each applications, we have like a lot of like more detailed models based on the neural network, because the different models have a different strengths. Some of the models have a very higher accuracy, but running like require more memory and longer latency time. So we provide the metadata describe those the properties of the model. So when you load the model, like I will introduce later in the demo about how you find your models in our model zoo. So okay. It's based on the category of the applications, the neural network architecture and version, and versus like what data set you are trained on.
How are the models stored? Like, is there a file format or a database or something?
Actually, we are pretty flexible. So you can store the models in your native format as like, for example, if your model originally trained in MXNet, you can store your model as originally MXNet or the model format. Mm-hmm. And in the model zoo, we provide a metadata to describe these models. This is how we find this model, and we define the model's properties.
Got it. The next question is, can you use DJL with ActiveJ for microservices?
Sorry, I'm not familiar with ActiveJ, but you can consider DJL is a normal Java developer, Java library. So you can combine it with any other Java applications and use whatever you want. So you just treat it's not the DJL itself. It's just a jar, right? Mm-hmm. So you can include the DJL into your application as normal, like a plain Java library. Okay,
we have two more questions at the moment. The first one is, what kind of applications can benefit from DJL? I'm having trouble with acronyms today, sorry. I've heard it being used for fire safety, counting number of people at a building. Can you think of any other fun ones?
First of all, it's DJL can be like a Java. DJL is a Java applications. It can run on any the environment. As I mentioned, you can run in the server environment, you can run the client environment, you can run on the edge as well. So for example, you can run on the Android framework, you can run on the even some the edge computing the hardwares. Mm-hmm. So it's almost anywhere that need a deep learning or machine learning use case, you can use DJL.
Okay, so it's on our members to figure out really cool creative uses then. That seems fair. The last question is a meta question. Is this deck available somewhere? And if not, can you copy and paste the URLs into the Zoom chat so I can paste them into the YouTube chat?
Which specific URL you are talking about?
The ones that were on the references slide that was just up.
Oh yeah, I will post it later. So I think someone can maybe, the main website is DJL UI, HTTP. DJL.ai. This is our main the website, and most of the links you can find through this URL.
Got it. So we should just go to the main URL and go from there.
Yes.
We are now caught up on questions, and I'm excited to see the demo.
Sure. Let me share my whole screen maybe. Okay. So yeah, so this is the full applications that run the object detections. You can see here, as I mentioned, how to load the models using we have an API called the criteria API. So we unify this API, allow you to load the models from our model zoo. The model can be from any URL from the website or from our model zoo, or even from your local repository, local file system. So it's very flexible. So as you said, if you don't know much about the machine learning and you want to choose the applications, you want to choose a model to solve your specific the problems, here's the way you can do. You can set the applications. They say, I want to load a model to solve the problem of the computer vision of the object detection, right? My input is the image and output is detect the object. And I can set the filter because there's so many models that can solve the same problems. And based on my performance, you can try different one. You can say I choose the backbone, right? The backbone could be like a MobileNet V2 or ResNet 50. Those are the machine learning neural network, the architectures. Probably you need to do a little bit of research about what they do and what their strengths of these models. And once you define the criteria, you pass it into our model zoo with load the model with this criteria. We are trying to find the best model for you, right? This is talking about the earlier questions about how can I choose the models. And later we are going to build a website about describe all the models we support. Beyond the 70, actually DJL is capable to load any models, not even not in our DJL repositories. You can find the models from MXNet Gluon CV, Gluon NLP models. We should be able to load the models as well. And you can find the TensorFlow, the TF hub and the PyTorch hub. They have a lot of like Hugging Face hub as well. So you can find a lot of those pre-trained models out there and you can bring them. We have the tutorials talking about how to bring those models inside the DJL and run it. So the reason we choose the building on top of existing models is that exactly because we want to leverage latest and the greatest technology involved in the deep learning the field. So for example, tomorrow, if there's a new models come out, which is trained in the PyTorch, you can use on DJL directly without any latency. We don't need to delay. You don't need to do port it, anything. So next, I'm going to run a Jupyter Notebook examples I showed in the slides. So you can install the Jupyter Notebook locally, and just run the Jupyter Notebook. It will open the browser. So those are the tutorials and examples we created in the DJL, the repository. So we have tutorials here. For example, we have teach you how to build your first neural network, train your first model, and run the image classifications. So I'm going to try the object detection examples from our model zoo. So you can see here, this is like the markdown format in the browser, and it's live. So when you open this one, you can just press the run to run this model. So you can see the model. So the syntax is very simple. We have some, this Jupyter Notebook have some syntax. Those are the Maven dependencies you want to bring out into this project in the page. So you can see here, you only need to include the DJL API. We choose use the MXN engine and the MXN model zoo. So the model will come from MXN model zoo. We organize our model zoo by engines. So you're going to see MXN model zoo, TensorFlow model zoo, and you can build your own model zoo with our API as well. So then your import, it's just normal, the Java import. And here is using the image factory. We have an image factory to abstract the image from for the different platform. The Android and the desktop and the Java using different image format. So you use the image factory, you can load from the URL. This is the image. So when you run this one, you can see here, the image will be show up here. It's very easy to understand what you're trying to do. This is the image with the dog, the bike and the car inside the image. Right? Load the image. And so here you just load the model. So we load the model and you can create a predictor and run the detections. The detection will tell you that in this image, there's a car, like there's a bike and there's a dog, and there's locations of the image. And we have a utility, the libraries help you to draw the bounding box on the image and show it. So here's the result. So you can just simply call our API, and you get the dog, bike, and the cars. So this is that simple, right? So this is one of the demo in the Jupyter Notebook. So another question is, you're talking about the where is our models? I think we have a list model. So if you check out our repository, we are using the Gradle to build systems. And if you run the Gradle command, list models, you are going to see the models available in the configurations here. So you can see a whole bunch of models we have. For example, this is CV action recognition. This is the artifact. This is a group ID. This is artifact, and their version and backbone. So you can see a whole bunch of the models. This is only for MXNet. You can choose in our documentation, you can find for the TensorFlow PyTorch models. Those are just the building models as well. Another one I want to show is, as I mentioned, we have DGL serving. It's a model server that you can use out of box. So when if you use the DGL serving, actually you don't need to the right code to do it. It's similar as the Tomcat. You can just in the Mac machine, you can just say brew install DGL serving. So it will just install for you. So because I already installed inside my machine, so it will just say you already installed. So brew already installed on this one. So once you install this one, you can use brew services. I don't know if I started or not. There's DJL serving. So this is it's not started. Saying I can start the service. So it will start the service in the background. And we in the DGL serving, we have a whole bunch of the REST APIs allow you to query the service. For example, you can register. We have a management API, so you can register a service. This is the URL. I just use the curl command to show you that you can use the Postman as well if you want. So this is the URL. Like say, I have a model in this HTTP locations. I want to load this model in our model zoo, where in our model serving. So you can see here. So the model has been registered. So the model is the example we're showing is a very small model. It's called the SqueezeNet. It's computer vision classification models. So once it's small, so it's downloaded very fast, and we download the model and the cache in the local. So you can see once this model loaded, you should be able to list the model. You can see here this model is already registered. You can register as many models as you want, and you can the DGL will auto scale when the concurrent requests come in, and it will create workers to serve your request. This is the model URL downloaded. So once you register the model, you can run a predict. So it's also the REST API, and you can just run this curl command. You can see this is a cat. This is a cat, and I list the top 5 probability of the object, the class of this this image. Yeah, and you can do the unregistered model if you are done with it. So yeah, so this is unregistered. If you do the list model, this list model is no longer there. I think that's pretty much for my demo. There's a more demos. You can find our GitHub, the website. Our GitHub website, we have a DJL demo website. We have a lot of applications here you can find. And we also, for example, we support a Quarkus integration. We have web demos. We have like the live object detection, Gravel VM integration, Camel integration, and all kind of stuff. So yeah.
We do have a few more questions. One of our members asked, when you were showing the tree with the probabilities, can you keep expanding that tree to see low probability events, or does it only show the high ones?
In the example, it's only show the high ones, but our API will list all of them. So you can expand it. There's a convenient API for you to iterate. We have a top K command. You can list the top K of them, or you want to enumerate all of them. Okay. But in the demo, we only show the 5 ones.
We had a question, is there any model that can perform semantic segmentation? And
yes, we do. We have a
semantic segmentation?
Yes, we do. We do have a semantic segmentations. Let me show you. I think I have the live code here. We have sentiment analysis, voice, instance segmentations here. So we can run these examples. Maybe I think it's bad. It's a little bit slow. Yeah, the model is big and it's loading.
Yeah. While it's loading, I'm going to take the opportunity to announce the winners because there's nothing like a live demo to have time to do something. Congratulations to Cheyenne Harry, the winner of our Agile Learner subscription. And also congratulations to Himansu Bera and Vinay Kavel for winning the IntelliJ licenses. We'll be reaching out to you over email with information about how to claim your prize. Hey, look, it loaded while I was announcing winners.
It's loaded, and they tell you the boundary, where is it? So the instance segmentation is different from object detection. Object detection just tell you what it is. Like instance segmentation is, you can tell you this instance is a dog, this instance is a cat. So in this image, I have a, let me show the image. It's showing that there are 2 bikes there. Yeah. Test resource segmentation. There's 2 bikes. You can see here. We have the output as well, so I can show you the output of the. So this is the instance. You can see here. It's the masks of the where the object is.
Cool.
Yeah.
We actually had 2 people ask this question. How did you run the Java kernel in Jupyter?
Oh, yes, we have an iJava kernel. So actually, we customized a little bit on the iJava kernel on the Jupyter notebook. We have an instruction on our website and in the Jupyter, the README folder, and it will show you how to install it in the Jupyter notebook.
Okay. And our final question, unless someone asks a question in the next minute or so, is in an enterprise application environment, what are some use case scenarios where you might use the DJL?
The one of the interesting is maybe I actually you can use almost anything, but one of them it's popular right now is because the recommendation system is pretty hot, and a lot of the recommendation system have a real-time requirement. So basically, they are dynamic training the model in the field, and like in short period of time, you get a new model you want to deploy. So this is very, very hard for the traditional like a Python-based training and the inference. So this is something like we are working with the Alibaba and also the Flink, Apache Flink, to make it happen. This is very cool applications I can mention about.
Okay, and that was our last question, so I will turn it over to Frank G.
Thanks, Gene. Frank, this is awesome. Thank you very much for a great presentation and really, really cool demos. I mean, I suggest people just go download that repo with all those examples. They look really, really cool. I mean, machine learning, I'm sure most people out there have heard me say this many, many times. Like machine learning, it's a new type of programming. It's to get used to it. It's a little different than what we're used to in terms of finding patterns and things like that. But it is a significant trend for all of us. So all of us in the Java community and all of us in the application community, not just Java, but elsewhere, really learn this stuff. This is really, truly important for all applications. I mean, you might not be looking for cats and dogs in an image, but you might be looking for other things. You might be looking for potholes, in a car, or you might be looking at defects in some manufacturing device, or you might be looking for some agricultural situation with how animals in a farm. I mean, it's really big problems that this stuff solves. So go on and just run these demos. And I want to thank Frank again for an awesome presentation. And thanks to Amazon for supporting Java and machine learning. Thank you very much. So that concludes our meeting. We have our after meeting. We have a little bit of fun. Too bad it's not physical, it's a virtual meeting. So that URL is in the chat, you'll see that. And we'll see you there in a few minutes. Again, thanks a lot, Frank.
Yeah, thank you. Give us such a good opportunities to introduce the DJL to the friend.
Quite welcome.
All right, thank you.
Bye-bye.